Right angle triangle trigonometry, finding angles. In trigonometry we do one of two things. We either find unknown sides or find unknown angles. We already know how to find unknown sides, and in fact finding angles is pretty similar. Sometimes they just give us a calculator question. This first pair of questions, there's two of them, A and B, they're just calculator questions. I know it doesn't look like it, but when they give us tan theta of 0.3, so tan of whatever the angle is 0.3, they're telling us that the ratio, the tan ratio for that angle is 0.3, but we just want the angle on its own. So I'll move my working up a little so that we've got a bit more space. We start by writing tan of the angle is 0.3, and we just want the angle on its own. Now we know that to get rid of something, we want to get rid of that tan, we would do the opposite of tan to both sides. And the opposite of tan is what we call inverse tan. And it's above the tan button. You can see there's a little tan to the power of -1. It means opposite tan. All it does is say to the calculator, when we do inverse tan, it says, hey, what angle has a tan ratio of 0.3? And we write it by saying tan with a little -1 sign, inverse tan, or opposite tan of 0.3, and we'll just do this in our calculator. That's all we need to do. So second function or shift and tan, and you'll see tan -1 and 0.3 equals, and it gives me the angle. Now we always round angles to the nearest degree, so that means 17 degrees. We lose a bit of accuracy. And if I said just, okay, what's tan of 17 degrees, it'll work out around about 0.3. Tan 17 around about 0.3. So what it means is, when the angle is 17 degrees in a right angled triangle, the tan ratio will always be 0.3. And this question was saying, hey, when the tan ratio is 0.3, what's the angle? So, when the cos ratio of an angle is 0.635, what's the angle? We do it the same way. Cos of the angle is 0.635, and we write just the angle, and we want to get rid of the cos and get just the angle, so we do opposite cos, inverse cos to both sides. And we'll do second function cos 0.635, 50.5, so an angle of 51 degrees has a cos ratio of 0.635. Let's check that. Cos of 51. A little bit more inaccurate there, you'll see, because we rounded, but about right. So all we're doing with this question is saying, when the cos ratio is this, what's the angle? And that's how we use the inverse cos or the reverse cos. It's for finding an angle. Now that's just a simple calculator question. Where we have this requirement to do this is, of course, when we're finding an unknown angle. And the steps are really similar to finding an unknown side. First step is always label the sides. I have the right angle, so that's the hypotenuse, opposite from the right angle, and the other side that's marked is next to the angle theta, So that's the adjacent. So I have adjacent and hypotenuse. There's nothing on the opposite, so I can't use it. My second step is always choose the ratio. Adjacent and hypotenuse means I use the cos ratio. And I write it always. Cos of the angle, cos theta, is adjacent over hypotenuse. My third step is always substitute in the values. These are the same as finding unknown sides so far. Cos of the angle is 3.1 over 5.2. Substitute the values in, and now you see it looks different to our finding a side, but our fourth step is still solve, and we learned how to solve it with the calculator up here. If I've got cos of the angle and I just want the angle, I do inverse cos to both sides. So I write theta equals inverse cos, cos with a little minus 1, and just leave it as a fraction. I could have divided it out, but I don't need to. 3.1 over 5.2. And I'm going to enter that all into my calculator. So inverse cos, well, let's just clear that for a second. Inverse cos, use the brackets if it's a fraction. 3.1 divided by 5.2, close your brackets, an angle of 53 degrees. And that's it. You've found the unknown angle. So one more question. Following my steps there. This one's tricky because they've actually given me all three sides. I've got hypotenuse of 13. Next to theta, I've got the adjacent of 12. And opposite the angle, I have the opposite. So this means I have all three sides. I can choose whichever ratio I'd like. So we haven't mentioned the sine ratio this time, so let's use sine so it doesn't get left out. But if you have more sides than you need, you can use whichever angle you want. So we choose a ratio, write the ratio. Sine is opposite over hypotenuse, don't forget theta. That's sine of the angle, opposite is 5, hypotenuse is 13, so we substitute that in. And then we rearrange. I've got sine theta, I just want theta. So theta equals inverse sine, sine with a little minus 1, of 5 over 13. We can just leave that as the fraction. And we do that on the calculator. Second function sine to get inverse sine, brackets, 5 divided by 13, close your brackets, and that's an angle of 23 degrees. So the most important thing to remember is that when you're finding an angle, you're using the opposite sign, cos or tan. Inverse with the little minus 1 in your working.